Hi everyone and welcome to the lesson. In this lesson we're going to be looking at passing structured data to function blocks. This is a really interesting lesson because this is the first lesson where we'll see the real benefit of using structures, and hopefully we'll start to put some of these concepts hand in hand and enable you to start sort of coming up with your own ideas on how you might use this approach. So working off the back of our previous lesson, this is exactly the same setup as the previous lesson in terms of what we're achieving. There are a few differences to this project, which is we've added another a global variable list. So this is system, and this is made up of another DUT or structure. And if we just have a quick look at what's in there, it's basically stuff that would be relevant to anything, any function block from a system point of view. So if a function block needs to know whether there's any alarms active, it's available here. If an emergency stop's been pressed, it's available in this structure. If it needs a timed second pulse, as in every 1 second there's a pulse, you can get it from this structure here. Now, I haven't written a function block that populates this information, but as a concept, we can see that moving this information around in the function block, how we'd utilize something like this. So if I go back to my PLC program, so I said earlier that this is the same as our previous lesson. Now, if you remember in the reading and writing lesson, there was a lot more stuff going on in here in terms of scaling and moving raw values around and all that sort of stuff. This has all been consolidated down into what I call a manager. So we have a pressure manager now, and I call it a manager because it is just a function block, but I call it a manager because it's expecting certain data types, and if it doesn't get those data types, then this isn't going to work. So let's have a look at what's happening in this manager. So first off, if you notice the two little arrows here, we are passing in and out. And if you remember what I mentioned in a previous lesson, is that if we're passing via in out, we're actually using a reference or a pointer, and the amount of information that is actually moved on that interface is much smaller than all of this information if it were to be copied on a input or an output. And I can demonstrate that if I log in under simulation and run this. You can see that the data type that is actually passed on the interface is a reference to DUT pressure, not the actual not the actual contents, just a reference. So everything that is on data here is actually looking at GVL.pressure1. All we're doing is passing how or where that information is. That has some massive benefits in terms of data usage. You'll fill your PLC up much quicker if you're using big structures and you're copying them on inputs and outputs all the time. I've seen this firsthand in older projects that I've worked with, and there is a massive memory saving to be made using in-outs. You can't always use them, and it's not advisable to always pass things on in-out, but big structures in the first function block that it's going to be used in, as in if you have other function blocks inside your pressure manager, for example, they should be passed as in-out to keep that memory usage down and to not make copies of the information everywhere. So let me log back out. If we go and have a look inside PressureManager, you'll see now that we're starting to make this look sort of functional. So we only have two rungs of information, logic, sorry, and the first one clearly tells us that we're doing scaling, and the second one tells us that we're monitoring or setting statuses. So compare that to our previous lesson where you could see multiple rungs and big interfaces with all the raw min, raw max, scale min. All of that has been consolidated down to a function, which is analog scale. And all this function accepts is a DUT analog, which we know resides in our pressure structure. So going back to our pressure structure here, we'll see that analog is a DUT analog. And all we're doing, because we now have DUT pressure on our PressureManager's interface, is data.analog. Now remember, we're passing by reference. This is also an inout, so we're still not copying any information here. We're still just pointing this to where the actual information is. And if we go in here, this scale function block here is another function block that I've written, or it's not a standard Codesys function block. And if we were to come into this, you'd find the actual standard. Now, there's nothing special happening around this. I could have just put this in the analog scale. However, by having it as its own function, I'm free to add stuff in my analog scale that is specific to analogs in the future. And that is something that you need to think about when you're using structures, because I'm passing a analog data structure, a DUT analog, into this. I need to make sure that everything is containerized so that if I need to add anything to this function block analog scale, it doesn't affect anything else that's in here. It's a bit hard to visualize when we're just doing one thing, but as we go on in the course and we look at some bigger systems, you'll start to appreciate why it's better sometimes to wrap things in another function, another interface via a function block. So at this point here, if we jump back up to our PressureManager, we are doing a scaling method or function, but we're still only passing one piece of information, which is the DUT analog that's nested in our DUT pressure structure. So coming down to status management, this one here is basically mirroring the interface of its parent, which is the PressureManager, the function block that we're currently inside. And it's asking for a analog data, which is the DUT analog, and also the system. So two variable inputs and outputs. So they're in-out. Remember, that's passed by reference. So coming into the analog status manager, what I have here is the same as what we saw in our previous lesson, with the generating statuses for out of range high, out of range low. But I'm also capturing when that status here, data status out of range. So that's a common flag for either status. When data status out of range goes true, we have a pulse high or an R trig if you want to use the actual function. A one shot that moves the system's current time of day into the data status diag out of range time. Now, I touched on this earlier that I like to have some diagnostics and statuses sort of wrapped up in my structures and in my functions. This is a good example of being able to put a timestamp on when this issue occurred. Now, on its own, a timestamp isn't that great. Chances are you're going to raise an alarm for something like this, so SCADA would be able to tell you when this happened. But if there's a lot going on and multiple things report things like this, you can start to paint quite a nice picture of, okay, this happened, and then at this time this happened, and this happened, and it can aid. I won't say that it will, definitely, but this is an example of being able to package some extra sort of niceties up in your structures, and thinking about them early on and building them into the structures just means that they're there if you need to use them or choose to use them. So let's come right back up to the PLC program. What we can see here is what appears on the surface to just be a straightforward function block, but actually inside there's a lot of breaking down of structures, accessing element data that is nested, that might be 3 or 4 layers deep, but right up on the surface you have a pressure manager that has no other requirements other than 2 structures, and really we only need to access the system because of that time of day. So if that wasn't included, we would just have a single interface here of a structure. So adding another one of these is as straightforward as creating a new network, and then if I go over to my POUs here and drag a pressure manager over, and I'll call this one pressure 2 manager. Let's remove that there, and again GVL dot pressure 2, and on my system is system dot typed. Now, as we go on through the course, you'll see more and more references to dot typed. Dot typed is, for me, is a way of me being able to see that this is a structure. It's of a particular type. So when I put system dot typed, I know that typed is the only sort of how do I put it? Is the only structure in this data block. This will become more apparent as we go into a lesson where we talk about sort of structured data versus bespoke data and how we can join the two together, so be able to add additional variables to a structured data source, such as a data block or a global variable list, without affecting the standard data set that is the structure. So right now dot typed doesn't really mean much, but it will mean more as this course goes on. So what we've done here is added a second pressure manager, and you can see everything's exactly the same except for we are now using pressure 2, which is still an instance of DUT pressure. So we effectively have standardized code now in our pressure manager, and we have standardized data sets in our DUT_pressure, and then we have a common interface or a standard interface that the function block provides, and all we do is give it the structure that it is expecting to see. So to summarize on all that, passing structures to function blocks has many benefits in terms of interface size is kept small. If we pass by inout, we pass by reference, which keeps the memory utilization small. And on the subject of modifying and enhancing this, if I were to update my pressure here, and I give it a new pool, for example, when I come into my pressure manager now and I try to access that on data dot, you can see new is already available. I haven't had to change my interface. From an actual data point of view, the interface has changed, and this would cause issues in terms of the size of memory changing that this block occupies. But for updating the actual program, if you had 100 of these objects that reference this new requirement, would you really want to go and add this to each one of those objects' interfaces? You don't have to with this approach, because obviously you just access it through the already existing DUT pressure. The data interface. So it keeps things nice and tidy. I really encourage that you sort of play with this approach and find out what works for you and the systems you design. I come from a sort of process background, but you might not, and what you're doing with PLCs might be very, very different to what I'm doing. So I really do recommend that you sort of download this, have a look at it, and convert it into whatever it is that you do, but follow the principles of create structures and pass those structures as inouts to your function blocks. And yeah, have a good go. And if you have any questions, just drop me a message on here, and I'll do my best to answer them.